Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30, 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down, so it would be 1, 2, 3, 5, 6, 10, 15, and 30. So 55% is the same as 55 over 100, and what I can do is I can divide top one of the fraction by 5, and so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The range is the biggest number, take away the smallest number. The biggest number in this demonstrative diagram is found at the bottom right. So this 9 here represents 69. So it would be 69, take away, and the smallest number is always at the top left. So this 4 here represents 34. So it would be 69, take away 34, which is 35. Here we have a triangle, and we've got an angle of 48 degrees. We've got this right angle, which is 90 degrees, and we're looking for x. So what we need to do is we need to realise that the 3 angles will add up to 180 because it's a triangle. So what we're going to do to find x is just subtract the 2 angles which we know. So we're going to subtract the 90 degrees plus the 48 degrees from 180. And in brackets we're just going to say the reason, and it's angles in a triangle add up to 180 degrees. So when we do that, we do 180, take away 90 plus 48, and you get 42 degrees. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it would be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. So 100% of 120 is 120. And let's put that in a bubble. So we're going to split that bubble up to find out what 10% is. And to find 10%, all we need to do is divide it by 10. So divide 120 by 10, you get 12. And then we want to split that bubble up again into 5%. And 5% is found just by halving it again. And so that would be, or just halving it, so that would be half of 12, which is 6. We could do with 1% as well. And we're trying to get to 26%, so we'll do 1%. So dividing the 10% by 10 again, 1.2. And we could do with 20%, and 20% just means we're going to double the 10%. So double 12 will be 24. So to work out 26%, we need to add these together to get to 26. So we're going to add these numbers here together. Okay, so we've got a 6, a 1.2, and a 24. And we're adding them together. And that would be 11, so carry the 1, and that would be 3. Now, it says to decrease it by 26%. So 26% is 31.2. So we need to subtract that. So we're going to do 120, take away 31.2. So I need to borrow 1 from the 2 to make that a 10, borrow 1 there to make that a 10, and that would be a 9. So 10 take away 2 is 8. 9 take away 1 is 8. And there's a 1 here, so we need to borrow that 1. That's 11 take away 3, which is 8. So our answer is 88.8. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1. So 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5, or 0.5. So our answer is 107.5. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom actually, that might be easier, and draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. To find the perimeter of a shape, you just find the distance around it. So you pick a point and just start walking around the shape. So we're going to walk down this side, and we're going to write down that 8. And we're just going to add all the lengths of the triangle that we go down. So the next one is 6 centimeters. So we're going to add that 6. And then finally, this 3 centimeters here. And we stop because we've returned to where we started. Add those together and you get 17. And the units will be centimeters because perimeter is a distance. So factorise means to put it into a bracket. And it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through 2 parallel lines, which are our 2 north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the 2 angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going till I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3. 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10. So the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. We're going to start off by just writing the decimal in the standard form, which is 4.3. And we're going to look at the power. Now, if the power is positive, it means the standard form number is a really big number. If it's negative, it means it's a very small number. And here it's negative, so we know it's a small number. Now we're going to do the amount of jumps that it shows in the power. So it says a 5 there, so we're going to do 5 jumps. And because it's a small number, we're going to go to the left to make it a small number. So we're going to go 1, 2, 3, 4, 5 jumps. So the new decimal point is going to be here. All the jumps that we made, we're going to fill in with zeros. And because it's decimal, we're going to start it off with a 0. So our new number is, or our ordinary number is 0.0004. 4, 3. Now it's important to realise that we shouldn't really think about it as jumping the decimal point. We're actually shifting the number, but it's all relative and it's a lot quicker just to move that decimal point. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. So this question is a simultaneous equations question. And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears, costs £7.80. or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8A. And so we're going to times the 2A by 8, which will be 16a plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the S in same is the S in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the D in different is the D in add. So here they are the same, so we are going to subtract. And we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of A, we know that A is £1 or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. So the thing we know about triangles is their angles add up to 180. So what we can do is we can say w squared plus 84 plus w plus 3w equals 180. And let's just put that together. So it's w squared plus 4w plus 84 equals 180. Now, with quadratics, whenever we're looking to solve, we want to have it equal to 0. So what we're going to do is we're going to take away the 180 from both sides, so it equals 0. So we've got the w squared plus the 4w, but we want to take away the 180 from it, which will give us minus 96 equals 0. So with quadratics, when we're trying to solve them, we need to put them into brackets. And to do that, we need two numbers that add together to make the 4 here and multiply together to make the 96 here. So just going through different numbers for 96, and you can try different ones. The first letter in the bracket would be w, first thing in the bracket would be w. And I think it's going to be, well, it's going to be a positive and a negative to get that negative there. 96 is 12 and 8, so it would have to be, let's have a think. It'd have to be a positive 12 and a negative 8 to add together to make a positive 4. And 12 times minus 8 is minus 96. That works. And to solve, we look at the left-hand side first and get that equal to 0. So w plus 12 equals 0, and then solve it. So get our lines in. Take away 12 both sides. W equals minus 12. And we get the left-hand or the right-hand side. Get that equal to 0. W minus 8 equals 0. Lines in. Add 8 both sides. W equals 8. Now we've got two answers here, but it says value of w. Well, we can't have a negative angle. So we know we're looking for w to be positive. So the answer must be 8. There are a couple of different methods for drawing a graph, and we're going to do the cover-up method. So I'm going to start just by writing out the equation. And what I'm going to do is I'm just going to completely cover up, and I'm going to do this with a little highlighter maybe. I'm going to cover up the minus 3y. I'm just going to cover up the y term. And so what that leaves me with is 10x equals minus 30. So if I get my solving lines in, I just need to divide by 10 both sides. So we've got x equals minus 30 divided by 10 is going to be minus 3. Now x equals minus 3 gives us the x-intercept. So we know that the x-intercept is minus 3. What is the x-intercept? Well, it's where the graph will hit the x-axis. So it'll hit it at minus 3. I'm going to do the same thing again. But this time I'm going to cover up the x term. I'm just going to cover this up. And so we're going to end up with minus 3y equals minus 30. Again, put my lines in. And this time I'm going to have to divide both sides by minus 3. And so we've got a minus divided by minus, which is a positive. 30 divided by 3 is 10. So our y-intercept will be 10. Y equals 10. So that will be here. And we know that the minimum amount of points we need to be able to draw a graph accurately, well, to draw a graph are 2. So if we've got 2 points, we can draw a graph. And here we do have 2 points. So I'm just going to draw in this graph as best as I can. And make sure your graph goes for the complete graph. Then make sure your line continues on for the complete graph, and don't just draw it between the x and the y intercepts. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.